Hi, let's get started with the worksheet for week 5. And question number 1 is essentially about change of basis and how we proceed through the mechanical computations for change of basis. So part 1a is asking us to take a vector alpha beta. And along with this vector alpha beta, we're also given two basis vectors. The first vector is 1, 0, and the second vector is 0, 1. And we are being asked to describe this vector alpha beta as a linear combination of these two vectors. So what number should we have here and here such that this sum ends up being alpha beta? And so the only way we can do that is to essentially have the number alpha multiply by the first vector and the number beta be multiplied by the second vector. Why? Because that would give us alpha times 1, 0, right? So alpha times 1, 0 is just equal to alpha 0. Beta times 1, 0, beta times 0, 1 is just equal to 0 times beta. And therefore, alpha times 1, 0 plus beta times 0, 1 is equal to alpha beta, which is exactly what we wanted to construct. All right, now for part B. So part B is asking us to do something very similar, but in this case our basis vectors are different, and the vector that we have to describe as a sum of those basis vectors is also different. So we have to take this vector BV and describe it as a linear combination of the columns of B. So what does that mean? We have to describe this vector BV as a linear combination of 1, negative 1 and 1, 1. So we need some number here and some number here. But what is BV? If we look at BV, that is just equal to B, which is 1, 1, negative 1, times B, which is alpha and beta. So BV has to be equal to alpha plus beta and negative alpha plus beta. And we want to be able to express alpha plus beta and negative alpha plus beta as some combination of 1, negative 1 and 1, 1. So what kind of coefficients can we choose such that this right-hand side is equal to the left-hand side? Well, if we choose the coefficients alpha and the coefficients beta for both vectors, we end up getting that exact sum that we wanted, right? Because alpha times 1 plus beta times 1 gives us the first element, and alpha times negative 1 plus beta times 1 gives us the second element. And that is the solution to part B. Now for part C. So as we saw in part B, there are some cases in which we can easily find out what kind of weights we should put on vectors to construct another vector. But in general, this is going to be slightly more difficult. And one example of that would be this example, part C, where we are given the vector 3, 4, and we're given the matrix 1, 1, negative 1, 1. Now, what we could do would be to do what we always do and just write 3 and 4 as a linear combination of these two vectors. But let's think in more detail about exactly what we are doing here. We're going to find some coefficients, alpha and beta, such that when alpha multiplied by the first vector plus beta multiplied by the second vector should give us the vector 3, 4 that we want, right? But that can be just written as, the right-hand side, as we saw in the last part, in part B, can be just written as B times the vector alpha beta. And so whenever we are trying to find a linear combination, so whenever we're trying to find the weights exactly for that linear combination, that's like solving a system of linear equations. And since the matrix that we're dealing with, this matrix B here, is invertible, solving this linear system of equations can be done by just simply inverting the matrix B. And so all we have to do in this case is to simply I'm just going to erase this part. So all we need to do to find alpha and beta, which are our weights that we need to find, is that I'm going to multiply B inverse times the matrix, times the vector 3, 4. And so step 1 would be to find B inverse, and the step 2 would be to find, to actually multiply B inverse with the vector 3 and 4. So let's start by finding what B inverse is. Since B is the matrix 1, 1, negative 1, 1, we know that B inverse has to be equal to 1, 1, negative 1, 1, divided by the determinant of this matrix, which is 1 times 1 minus negative 1 times 1, which is equal to so we know that B inverse has to be equal to 1 over 2 times 1, negative 1, 1, 1, which is equal to half, negative half, half, and half. And so to get our alpha beta, we just need to multiply this matrix, half, negative half, 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 by the vector 3, 4. And what do we get when we do this? We get that our alpha has to be negative 1 over half, and our beta has to be 7 over 2. That's a 7. And that's the vector that's the vector that we need. In general, whenever you're given a vector, instead of 3, 4, if it's any vector, I don't know, v1, v2, all you need to do is that you need to multiply the inverse of matrix B with that vector. Now for part D. So we have a vector VB, and just to recap, all that VB is that B times VB gives us whatever vector that we wanted to start with. So in part C, we had a vector 3, 4, and all we were doing is that we were saying that B times VB should be equal to 3 and 4. And we made this equation to express the idea that the vectors of, the elements of VB, so the first element of VB times the first column of B, which was 1, negative 1, plus the second element of VB times the second column of B, so 1, 1, that should give us 3/4. So we took this sum, this linear combination, and we wrote it down as a matrix equation, and we said that B times VB should be equal to whatever vector we start with. In this case, it was 3, 4. It could be anything else. Now, the part D is basically asking us to go in reverse. In part C, we went from V to VB. Now we have to go from VB to V. And so how would we do that? So let's say there was some V, and we wanted to go to VB. And to go to VB, what we did was we started with V, and we multiplied V with B inverse, and that gave us, sorry, this is a B inverse. I'm just going to write it again. This is a B inverse, and we multiplied it with a vector V, and we got a VB. Now the question is, how do we go back? How do we get V from VB? How do we get V from VB? And the answer is simple. We just, V is equal to B times VB. It's the exact equation that we started with while trying to solve C. And that's all there is to part D. Thank you.